Have you ever wondered why people throw salt on ice? It might sound a bit strange at first. Most of us know that salt melts ice, so how could it possibly make things colder? Today we're diving into this cool science mystery. Get ready to discover how salt doesn't just melt ice, it can actually make the ice even colder than before. Let's break down the science behind this everyday phenomenon and see why it's not as simple as it seems. Ready to have your mind blown by some frosty fact? Let's get started. Start with the basics. Normally, water freezes at 0 degrees C. That's the temperature where liquid water turns into solid ice and stays stable. It's a familiar concept. Think of your freezer at home or a frozen pond in winter. At this point, the water molecules slow down enough to lock together and form solid ice. But what happens when we add something extra like salt? That's where things start to get interesting and the science takes a surprising turn. Now imagine you sprinkle some salt onto the surface of ice. What's really happening here? The salt doesn't just sit on top. Instead, it starts to dissolve into a thin layer of water that forms on the ice. This is where the magic begins. The interaction between salt and ice is more than just a simple mix. It's a chemical reaction that changes the rules of freezing and melting. Let's see how this process unfolds and why it matters. Here's the key scientific point. When salt dissolves in the thin layer of water on the ice, it lowers the freezing point of that water. This means that the water can no longer freeze at the usual 0 degrees C. Instead, it now needs to get even colder before it can turn back into solid ice. This process is called freezing point depression, and it's a fundamental concept in chemistry. It's the reason why salted ice behaves so differently from regular ice. But with the freezing point lowered, the ice starts to melt, but not in the way you might expect. To melt, the ice needs energy. Where does it get this energy? From its surroundings. The ice absorbs heat from the air, from your hands if you touch it, and even from nearby objects. This absorption of heat is what makes the temperature of the ice-salt mixture drop even further. It's a fascinating chain reaction that leads to some chilly results. As the ice absorbs heat to melt, the overall temperature of the mixture drops. In fact, salted ice can reach temperatures as low as 18 degrees C or even lower. That's much colder than regular ice, which stays around 0 degrees C. This is why when you touch salted ice, it feels much colder than plain ice. The process of melting actually pulls heat away from everything nearby, creating an extra cold environment. Pretty cool, right? You might have seen trucks spreading salt on icy roads during winter. This isn't just to melt the ice and make driving safer. The process also makes the road surface extremely cold. As the salt lowers the freezing point, the melting ice absorbs heat from the environment, making the surface colder than before. This helps prevent refreezing and keeps the roads safer for everyone. It's a practical use of science in everyday life. Here's another fun example, making ice cream the old-fashioned way. Before modern freezers, people used a mix of ice and salt to freeze ice cream. The salted ice mixture could get much colder than regular ice, allowing the creamy mixture to freeze quickly and smoothly. This method is still used in some homemade ice cream recipes today. It's a delicious demonstration of how science can make treats even better. Want to see this science in action? Here's a quick experiment you can try at home. Place an ice cube on a plate and sprinkle some salt on top. Wait a few seconds, then carefully touch the ice. You'll notice it feels much colder than before. This hands-on activity is a great way to experience the effects of salt on ice firsthand. Just be careful not to keep your fingers on the ice for too long, it really does get cold. You might be surprised at just how cold the salted ice feels. That's because the melting process absorbs heat from your skin, making the sensation even more intense. The science behind this is all about energy transfer. Heat moves from your hand into the ice, causing the temperature to drop rapidly. It's a powerful demonstration of how a simple ingredient like salt can change the way we experience cold. Let's take a closer look at the chemistry. When salt dissolves in water, it breaks into ions that interfere with the formation of ice crystals. This disruption is what lowers the freezing point and allows the mixture to get colder than normal. It's a great example of how chemistry isn't just something that happens in a lab, it's happening all around us, even in your kitchen or on a snowy street. Science is full of surprises, especially when it comes to things we see every day. Who would have thought that adding salt to ice could make it colder instead of warmer? This simple trick is used in everything from road safety to making tasty desserts. It's a reminder that there's often more to everyday actions than meets the eye, and that science can make the ordinary extraordinary. Let's recap what we've learned. Salt doesn't just melt ice, it changes the way ice and water interact. By lowering the freezing point, salt allows the ice to absorb more heat and get colder than usual. This process is used in real life for safety, fun, and even food. It's a perfect example of how a little knowledge can change the way we see the world around us. Next time you see salt on icy roads or make homemade ice cream, you'll know the science behind it. Understanding these everyday phenomena can make life a little more interesting and a lot more fun. Science isn't just for textbooks, it's happening all around us all the time. So keep asking questions and exploring the world with curiosity. Thanks for joining us on this frosty science adventure. Remember, the world is full of fascinating facts just waiting to be discovered. Whether it's salt on ice or something else entirely, there's always more to learn. Stay curious, keep exploring, and never stop asking why. Until next time, keep it cool and keep loving science.